Today I will show you how to operate a Oxford Instruments IPS 12010 power supply. This power supply one can use to ramp up the magnetic field of a superconducting magnet. So what we have a superconducting magnet with a maximum field 8 Tesla. So we'll try to see how this power supply actually functions. So this is the button to switch it on. So as soon as you switch it on, then you can see there is a green LED light, and now you can see there are many buttons here. So first of all, this is the front panel. One can use this power supply or operate this power supply through a computer by using some kind of interface, some kind of software given by this Oxford magnet. But I want to give you some kind of manual instruction how to use this power supply. So you see, there are many knobs, as I already mentioned, many buttons. So initially you can see there is the output clamped mode. So in this mode you cannot really apply, you can really operate this power supply. So what you have to do, you have to change the mode output clamped to hold mode, then you can immediately hear a sound. So what you have, this is the output current and this is the output voltage of this device. Okay, so what you can do, you can change the mode from Tesla, the field mode, to current mode. To do that, you have to press this button, then this device will show everything in the ampere mode. Yeah, but we don't want to do these things. We want to see in the field mode unit in the Tesla. So then let's switch back to the Tesla. So to really ramp up a field, first of all, in a superconducting magnet what you have a superconducting coil, and then superconducting coil is connected to a superconducting switch. So there is a switch heater. So you see we are now in a control mode. There is a control mode, you can do it local, and as soon as you connect to this computer and you want to connect it from the remote, then this button can change. So now in the lock mode, so therefore we are in the local mode. So let's see, first of all you have to make our switch heater on so that you can really ramp the current into the magnet from the outside. So now I make the switch heater on. So now as soon as the switch heater is on, then actually you can try to ramp up the field. So let's see what is the situation of the magnet. So this button tells you about the information on the magnet status. So you see, as I press the button, it shows 0, 0, 0, 0, 0. So that means you have the magnetic field is actually 0 here. If you now want to set the magnetic field to your desired value, for example, I want to make a field around, let's see, for set point what is there. So you see there is a set point of only 0.1 Tesla here. So let's see so therefore maybe let's try to go to 0.1 Tesla. If you really want to go to 0.1 Tesla, so this is your set point, and then what you have to do, you have to make your set rate. So that means how much current you want to provide to your magnet. So that means the ramping up of the field. So we have a set rate of something 0.2 Tesla per minute. So in this situation now, that means you want to go to a kind of magnetic field of 0.1 Tesla, and the 0.2 Tesla is 0.2 Tesla per minute is the ramping rate. So now you just make a press button to go to set, and you see immediately that started to ramping up the field. Yeah. So you can, in principle, increase the set rate by changing the set rate from 0.2 Tesla per minute to maybe 0.5 Tesla or something like that. But one thing one has to be remembered, that as soon as you are in the actually low field regime, so the set rate is maximum you can do with this configuration 0.8 Tesla per minute. But if you really want to go something 7 Tesla or 6 Tesla, then it is really important to check what is the limiting sweep of your field. So now you see we have a 0.1 Tesla magnetic field. Yeah. So this is now in the still the magnet is in actually the driven mode. Now let's see, we want to kind of change our set rate. So if you really want to change your set rate, for example, set rate 0.2 Tesla to you want to set rate to 0.3 Tesla. So that means you have to change this button, or you want to set rate down to maybe 0.25, then you just have to lower this value, something like that. Yeah. So equivalently, set point you can also change some 0.2 Tesla by raising, maybe you see this is 1.105. This is 0.11 Tesla. Similarly, you can go to lower this to send to 0.10 Tesla. So this way you can change all the things. Now, what you want to do, let's think that you don't want to keep the magnet in a driven mode, but rather in the persistent mode. So that means there is persistent mode means you have a really less loss, and there is no energy loss of your superconducting magnet. To do that, what you have to do, for example, at 0.1 Tesla, you want to make your system in a persistent mode. Then to do that, you just have to make the switch heater off. Yeah, so that means there is no switch heater, so that means the additional switch heater is off. Now you just make to you want to change your value to 0. So you press the button, go to 0. So now you see it shows that you don't really have a field, but you see there is this button shows the persistent mode. So that means now in your magnet is actually in the persistent state. So to check what is the status of the magnet, you just press the button, that immediately you can see 0.1 Tesla. So in this way you can really run your power supply. Now we want to return back to our original condition, and we want to make the magnetic field to 0. So to do that, what you have to do, first you have to bring back to your magnet to its original state. So you see your magnet status is 0.1 Tesla, so that means you just make sure, just try to press the button go to set, and then immediately you see this is 0.1 Tesla. But then to really return, you have to bring your back in the driven mode, so that's why you have to make your switch heater on. So now your switch heater on, and then magnet is in the driven mode, and you have a 0.1 Tesla of your magnetic field. Now if you want to make your magnetic field, make your magnet to at the 0 magnetic field, then just you have to press the button go to 0. Then it will take your magnet to 0 field slowly. So that means by using this all the knobs, you can in principle change your field from 0 Tesla to the desired field. The same thing you can also do by using, as I told you, using this software connect of some kind of interface. But sometimes it's good to know manually how whole things actually works. So this power supply essentially connected to another our helium level meter. So below some percentage of the helium level meter, immediately this power supply goes back to its 0 field. So now the magnet goes to 0, so you can actually make your switch heater off, and then you can go to the magnet hold mode, and then you can switch it off your magnetic power supply. And this way actually your IPS 12010 Oxford Instrument power supply one can work.